As we move into here to our study on genetics, one of the first things we have to learn about is something called probability, because that's basically when we study genetics and the passing of traits, that's what it's all about. So what is probability? Probability simply is the likelihood that something will occur. Okay, how likely is it that this trait's going to be passed on or that trait is going to be passed on? Now we're going to look at probability here by looking at something really simple such as flipping coins, as rolling a dice, and we'll actually be doing a lab the next class in which you will be doing this. Okay, you guys know if you flip a coin, picture below, what would be the chances the coin would land heads up? Well, there's one heads and there's one tails, and you guys all would say you have a 50% chance, and you would be right. Okay, so we say the probability is 1/2 or 1 out of 2 or 50%. If we were to roll a die and ask, for example, what's the chances or what are the odds that you will get a 6? Again, we know there's 1 6 and there are 6 sides to the dies. You have a 1 in 6 chance of getting a 6. Okay, that is basically probability at its simplest. So let's go through here and we're going to use probability and talk about how probability works. Okay, as we mentioned earlier, a heads up was 1/2 or 50%. Getting a 6 up is 1 out of 6. Okay, but why is that the answer? And I kind of explained it before. Probability is simply calculated as the individual events, or the number of individual events, divided by the total events. And as I mentioned with the coin, there's only one heads, but there are 2 sides, or 2 total possibilities. So you have 1 out of 2. Same thing with rolling the die. There is only 1 6 on the die, but there are 6 total sides, or 6 different numbers on the die, so 1 over 6. That is how you calculate probability. So as we move on, if you flip the coin, what would be the chances the coin would land heads up on the second flip? Okay, well, if we look at that, or if we roll the die, what's the chances it will end up a 6 on the second roll? Again, we know heads up or 6 up is 1/2 and 1 6. But again, why does it stay the same? This is called the rule of independent events. Okay, and we will talk more about this rule when we actually get into genetics. Okay, so that is why, again, we are studying probability first. But basically, what this rule of independent events is telling us is that the first flip has no effect on the second flip, or the second roll of the die had no effect, or excuse me, the first roll of the die had no effect on the second roll of die. They are independent of each other. The second flip is independent of the first flip. The second roll is independent of the first roll. Okay, and this is one of the key rules that we have to understand when doing probability. And when we get into Mendel's principles of genetics, we'll be talking about this again. So again, rule of independent events simply says the probability that one event occurs is no way is affected by the probability of the other event occurring. In other words, the second flip is not affected by the first flip. Just because you get a heads the first time doesn't mean you have to get a tails the second time. Same thing with rolling the die. So this time we're going to flip 2 coins instead of 1. What would be the chances that the coins will both land heads up? Okay, or if we use our die, instead of rolling 1 die, we're going to roll 2 die, and what are the chances that they are both going to be 6s? Now this is different from rolling 1 or flipping 1 coin twice or rolling 1 die twice. Now we're doing both coins at the same time and both die at the same time. So what happens here? Okay, in this case, our probability changes. It is no longer 1/2, it is now 1/4. Okay, if we look at the die, our probability happens to be 1 out of 36. So why does it change? This is called the multiplication rule of probability. So let's look at that rule. Okay, we just talked about the rule of independent events. Okay, now let's talk about when we have simultaneous events occurring at the same time. If we have simultaneous events occurring at the same time, we must use the multiplication rule of probability. So what does that rule tell us? The multiplication rule of probability simply states that the two events both occur is equal to the probability that event A occurs times the probability of event B occurring. Okay, again, the key part here is that you are multiplying. You're taking event A, coin 1, times the probability for event B. So we're going to look at each of the coins as they flip. We know the first coin has a 1 in 2 chance of being a head. We know the second coin has a 1 in 2 chance of being a heads, or 50% chance. So the chances of them both coming up heads is the product of the individual probabilities. We multiply. If you have a product, you are multiplying. So the overall probability of getting 2 heads is 1/4. We do the same here for the coins. We roll our 2 die, We know the first die has a 1 in 6 chance of becoming a 6. We know the second one has a 1 in 6 chance. For these to occur simultaneously, we find the product. That means we multiply. So the odds of getting 2 6s is 1 out of 36. Okay, 1 out of 36. So that is our second rule that we have to pay attention to. Okay, to put this in terms that we'll be talking about later, this would be something that maybe when parents are expecting twins. Okay, what are going to be the sex of the children? Okay, now as we continue through our rules for probability, okay, this time we're going to look at cards, and a card is drawn randomly from a deck. You guys should know a deck consists of 52 cards. You will win $10 if the card is a spade or an ace. What is the probability that you will win the game? Okay, so spade or an ace. So again, let's use our rules of probability. Okay, you have a 4 in 13 chance, okay, of getting this. Why is that? Why do you have a 4 out of 13 chance of getting a spade or an ace? Okay, so let's figure out why that is the correct answer. This is called the addition rule of probability. Okay, this is our third rule that we have to look at so that we can better understand how genetics works. Okay, so what does the addition rule say? The probability that event A or event B occurs. Okay, this is not an and statement, this is an or statement. Is equal to the probability of event A plus the probability of event B minus the probability of both events A and B occur. So that last part there is a little tricky. So let's talk about it. You have a 13 out of 52 chance of drawing a spade because there are 13 of each suit in the cards. There are 52 cards. You have 13 spades. You have 13 hearts, 13 diamonds, 13 clubs. So you have a 13 out of 52 chance of drawing a spade. You have a 4 out of 52 chance that you're going to get an ace since there are 4 aces in the deck. And then you're going to have to subtract one of those because the ace occurs in both situations. The ace here and the ace here. Okay, so we subtract that 1 out of 52 because these occur in each situation. The result is 16 out of 52. That equals 4/13. Okay. Again, we like to give our probability in the lowest term. So again, 4/13, 1652 is acceptable, but you should try to reduce it the best you can. Again, you have to pay attention to this part right here. This is the part that most people forget. Since this can occur in either situation, we take that out when calculating or doing the addition rule of probability. Okay. So, again, what are our three rules here? We have the rule of independent events. One event in no way affects the outcome of a second or following event. Multiplication rule, what's the chances that two things will occur simultaneously at the same time? Okay, and third, your addition rule, probability event A or B occur is equal to the probability of A plus B minus the probability that both events occur. So those are your three primary rules. And as I said, we're going to be doing some activities here, or a lab, the following class to go over this. Okay, so again, if you need to, go back over this quickly. Make sure you understand these three rules, and we will be doing our lab following that.